Welcome back. Today we're going to be talking about the area of a composite figure. So essentially, a composite figure is a figure that is made up of other figures. So basically, to find the area of a composite figure, we need to find the area of each part of our figure and add up the results. So here's just a list reminding us of the area of each of these figures individually. So we will take all of them and add them up depending on the situation. So, starting with this first example, I noticed that there are two regular figures made up of this composite figure is made up of, right? Those two figures are this rectangle, like that, and then this triangle, like that. So, first, I'm going to find the area of the rectangle, then the area of the triangle, and then we're going to add those both up to find the area of the figure overall. So let's start with the area of the rectangle. So area of a rectangle is length times width. In this case, the length is 3 feet, and the width also is going to be 1 foot. So it's going to be 3 times 1, and 3 times 1 is 3. So the answer is 3 square feet. Next, let's find the area of the triangle. Now, the area of a triangle is equal to base times height divided by 2, or you may have seen 1/2 base times height. Either way is the same thing. So now let's talk about, well, what is the base and what is the height? So we know that this length here is 1 foot, and when it comes to a rectangle, the opposite sides are congruent. So therefore, this side must also be 1 foot. So the base of this triangle is 1 foot. The height is also 1 foot because this arrow pointing to it tells us that this height is 1 foot. The reason we know that this is the height is because it's perpendicular to the base. Notice this 90-degree angle. That is always something right there that we want to look for when determining that we have that is the height of the triangle, that it has a 90-degree angle with the base. And unless the triangle is a right triangle, the height is not actually going to also be a side length of our triangle. So needless to say, our base in this case is 1 foot, and our height is also 1 foot as well. So therefore, base times height over 2 is equal to 1 times 1 divided by 2, which is 1 over 2, so 1/2 of a square foot. So now let's talk about the total area. The total area is just going to come from adding these things up. So adding 3 square feet plus 1/2 of a square foot, and that gives me 3.5 square feet. And there's our solution. Okay, let's try another one. So with this one, it looks like this is a rectangle with kind of some half circle bites cut out of it. So when it comes to this one, we're actually going to subtract. We're going to say the area of this figure is going to be equal to the area of this full rectangle, and then minus these two half circles. So the area of the total in this case is going to be equal to the area of the rectangle minus the area of the half circles, which I guess in total the half circles will make a full circle. So overall we'll take out a full circle because we have half of it over here removed and half of it over here removed. So before we worry too much about that, first let's find the area of the rectangle. So area of the rectangle is going to be length times width. In this case, length is 28 and width is 15. So then I want you to go to your calculator and type into your calculator to find out what 28 times 15 is. And if we do that, we get 420. So therefore the answer is 420 square inches. So if we were finding the area of the full rectangle, that'd be the answer. Now at the end of the day though, this rectangle has 2 bites cut out of it, 2 half circle shaped bites. And so what we need to do is we need to find the area of one circle because these 2 half circles together will make a full circle. So the area of the half circles is equal to pi r squared. Now, if it was just one half circle, it would be pi r squared divided by 2, but since it's both half circles, those two add together to become the area of the full circle. So that's why I'm using the formula for area of a full circle in this situation. So then what I'm going to do is identify what the radius is. Well, it looks like this full diameter that goes from one end of the circle to the other is 15 inches, and we know that the radius is equal to the diameter divided by 2. So in this case, the radius is 15 over 2, or 7.5. So therefore, the area is pi r squared, which is going to be pi times 15 over 2 squared. So then we're going to calculate we're going to type into our calculator 3.14 times 15 over 2 squared. Or you could use 7.5 squared instead if you wish. So then if we do that, we get 176.625 square inches. So that's basically the area that is cut out by these two half circles together. So then what I'm going to do is say, well, that means the total area is equal to the area of the rectangle, which was 420 square inches, minus 176.625 square inches, which is equal to 243.375 square inches. So the area of the figure after the two semicircles have been cut out of the rectangle would be 243 square inches. All right, and that is everything for today. If you have any questions about any of this, feel free to leave those in the comment section, and we'll see you for the next one.